This is the site from which the United States will, before the end of this decade, launch its first manned mission to explore the moon. This is the National Aeronautics and Space Administration's Launch Complex 39, Pad A, at the John F. Kennedy Space Center. In working toward the Apollo lunar mission, the nation is developing an extensive capability for manned space exploration. It is molding the team, manufacturing the hardware, conducting the development ground tests, building the facilities, training the flight personnel, performing the flight operations. While in the past year emphasis has been centered on space vehicle development testing, long strides forward have been made in all areas. The progress is typified by the advancement at the John F. Kennedy Space Center's Launch Complex 39. Here, the Apollo Saturn V transporter was transformed from a 5.5 million pound stockpile of steel into the world's largest land vehicle. Mobile launching structures were transformed from a first early assembly into towers 447 feet high. Each tower weighs approximately 11.5 million pounds. And the vehicle assembly building was transformed from a cluster of pilings into a 400-foot steel framework. The completed building will stand over 520 feet high. Progress such as that at Launch Complex 39 during the past year can be achieved only through the teamwork and cooperation of many people. For the manned spaceflight programs, NASA has assembled a government industry team of near 300,000. The team is directed by the Headquarters Office, Washington, D.C., and 3 field centers: the Manned Spacecraft Center, Houston, Texas; the Marshall Space Flight Center, Huntsville, Alabama; and the John F. Kennedy Space Center, Merritt Island, Florida. More than 90% of the work is performed by contractors spread across the nation: Downey, California; Bethpage, New York; New Orleans, Louisiana; St. Louis, Missouri; Daytona, Florida; Burbank, California; East Hartford, Connecticut; Milwaukee, Wisconsin; Cedar Rapids, Iowa. In fact, some 20,000 prime contractors, subcontractors, and suppliers in every one of the 50 states are participating in the manned spaceflight programs. The government industry team efforts of the past year moved all areas of the program significantly closer to operational flight phases. In manufacturing and testing for Gemini, the program for long-duration 2-man missions in Earth orbit, McDonnell Aircraft proceeded with final assembly and factory checkout of 3 spacecraft for manned missions. One of the 3 is scheduled for the first rendezvous and docking mission, the perfection of this maneuver being a major program objective. In addition, Lockheed Aircraft proceeded with fabrication of Gemini Agena target vehicles in Sunnyvale, California, completing the first and delivering it for an early 1965 static firing at Santa Cruz, California. Steady progress was also predominant in Apollo, the program to achieve the lunar landing and preeminent capability in extended manned spaceflight. Throughout 1964, North American Aviation, Downey, California, and subcontractors continued development testing of spacecraft and associated equipment. For instance, dropping development test vehicles from aircraft to check out Northrop Ventura parachute Earth landing systems, investigating the structural effects of water impacts, performing functional tests of Pratt & Whitney fuel cells, checking out ground equipment such as a tilt table to be used in guidance and navigation systems tests. During the same time, NASA, the Chrysler Corporation, and Douglas Aircraft completed manufacturing of Saturn I vehicles. In October, NASA and Chrysler conducted the final acceptance test firing for Saturn I first stages, climaxing a highly successful program. In the Apollo program's second phase, Apollo Saturn 1B, the government industry team advanced across a broad front toward this nation's first 3-man Earth orbital missions. At the end of 1964, North America neared completion of structural assembly for the spacecraft command and service modules for the first Apollo Saturn 1B launch, a highly significant test of an all-systems-up vehicle. and the company began installation of initial systems early in 1965. Subcontractors, meanwhile, assembled components of systems such as stabilization and control equipment built by Honeywell, the command module reaction control system built by Rocketdyne, and heat shield ablation applied by Avco. Progressing in step with the spacecraft was the first Saturn 1B flight test launch vehicle. On an assembly line at the NASA Michoud plant near New Orleans, Chrysler completed assembly of the first stage in November 1964 and undertook final checkouts in preparation for static firings. For the first flight vehicle's second stage, Douglas completed major assembly at Huntington Beach, California in the fall of 1964. During the same period, contractors continued fabrication and qualification of ground test hardware. In October, Chrysler and Ling Temco Vought converted the Saturn I dynamic test first stage to the 1B configuration, following completion of the Saturn I dynamic test program. The stage was shipped to Marshall in late December. Douglas, in the meantime, completed the dynamic ground test second stage and shipped it to Marshall, the first flight-type stage to be built. The dynamic tests were scheduled to start in February of 1965. Additionally, Douglas erected another second stage ground test vehicle at the Sacramento test operations, installed the J-2 engine, and in late November fired the vehicle in a short duration test, the first hot firing of a Saturn 1B second stage. Following 3 additional short-duration firings, the first long-duration firing, about 7 minutes in length, was successfully performed in late December. The final major section of the Saturn 1B is the instrument unit. For components of the instrument unit, NASA and IBM began development tests of items such as the radar altimeter and cold plates. The achievements in Apollo's Saturn 1B were matched by those in Apollo Saturn V, the vehicle for the manned lunar mission. For the spacecraft, North American completed final engineering hard mock-ups for the command and service modules to be used in the lunar mission. In the fall, NASA approved the configuration of the mock-ups, design work being near complete. A short time later, NASA approved the basic design of the first lunar excursion module hard mock-up built by Grumman Aircraft, Bethpage, New York. Design work was more than 90% complete. Another mock-up, completed in the spring of 1964 by Boeing at NASA Michoud, was the one for the Saturn V first stage, 33 feet in diameter, 138 feet in length. Using the mock-up to check manufacturing techniques and procedures, NASA and Boeing continued building hardware, including the first several flight stages. Hardware already in fabrication will be used in the launch vehicle for the lunar mission. NASA and Boeing had also nearly completed fabrication and assembly of a first stage static firing test vehicle by the end of 1964. This was the first live Saturn V first stage. In the first stage of F-1 engine development, Rocketdyne passed a milestone in December when it completed a series of static firings, establishing flight rating for the engine. In the manufacturing and development testing of Saturn V second stage ground test hardware, North American achieved a first on November 9th with the ground test vehicle's single J-2 engine firing. The company then began mounting the vehicle's remaining 4 J-2 engines to conduct full static firings. In its new Seal Beach, California facility, North American also moved ahead with the assembly of a structural test stage, completing the critical assembly of a common bulkhead, welding the bulkhead to a liquid hydrogen tank cylinder, hydrostatically testing the assembly, and preparing for completion of the vehicle. And just at the end of 1964, North American's Tulsa, Oklahoma plant began fabrication of the first flight test second stage. Work also progressed for Saturn V's third stage and instrument unit, which are virtually identical to the Saturn 1B second stage and instrument unit. For all sections of Saturn V, basic design was completed in 1964. Accomplishments equal to those in space vehicle manufacturing and development testing were recorded in the construction of necessary development and pre-flight test facilities and checkout equipment. For example, acceptance checkout equipment stations such as the one installed by GE at North American. The Spacecraft Propulsion System Development Facility at the NASA White Sands operation, New Mexico. Space environment chambers like those at the Manned Spacecraft Center. Manufacturing and test facilities such as those at NASA Michoud. The Marshall Test Stand for development static firings of Saturn V first stages. The NASA Mississippi Test Facility Complex for acceptance static firings of Saturn V first and second stages. As hardware and facilities advanced toward manned missions, flight operations personnel prepared for their roles as mission directors and monitors and as flight crews. The flight crews, who will function both as scientists and pilots, took part in widely varied activities. For instance, they participated in spacecraft development and evaluation. They utilized trainers such as the Gemini Translation and Docking Simulator in general preparation for missions. They took part in spacecraft checkouts and simulated flights in preparation for specific missions, such as the first manned Gemini flights. And in October, NASA began accepting applications from scientists to serve on flight crews for future missions. By the end of the year, NASA had received 1,000 applications. The government industry team, meanwhile, proceeded with unmanned flight test operations, launching the first Gemini vehicle from the Air Force Eastern Test Range, Cape Kennedy, on April 8th. Primary objectives successfully met were to verify the structural integrity of the space vehicle and to prove the capability of the launch vehicle to place the spacecraft into a prescribed Earth orbit. The second Gemini flight test, an unmanned suborbital mission, was launched on January 19th after several weeks of delay caused by a malfunction in a launch vehicle hydraulic system. Primary objectives included proving out spacecraft heat protection, demonstrating the spacecraft's structural integrity, and flight verifying numerous spacecraft systems. Throughout the mission, the trajectory was well within the programmed envelope. The spacecraft reached an altitude of approximately 100 miles, then re-entered the atmosphere and splashed into the Atlantic Ocean some 2,100 miles downrange. There it was recovered by Navy and Air Force units and NASA. The test objectives were achieved, and Gemini was declared ready for man. For launch number 3, which will be the first manned Gemini mission, the spacecraft was accepted by NASA at McDonnell in December 1964 and delivered to Cape Kennedy. It was immediately installed in test facilities for pre-flight checkouts. 3 days after delivery, the flight crew and test personnel began communications interference tests. Flight tests for Apollo were in progress at 2 locations, White Sands and Cape Kennedy. At the Army's White Sands Missile Range, NASA and contractors launched 2 Little Joe 2 vehicles in development tests of the Apollo rocket escape system under launch abort conditions. In both tests, the escape system fulfilled all objectives, and the parachute landing system returned the command module to Earth within tolerances safe for man. At Cape Kennedy, 3 Saturn I vehicles, SA-5, SA-6, and SA-7, were launched, continuing an unbroken string of 7 successes. SA-5 was the first flight test of a Saturn I with 2 live stages. Objectives of the flight included proving out vehicle structures, propulsion, and control systems. The vehicle was launched on January 29, 1964, and it placed its payload, instrument unit, and burned-out second stage, a total of 19 tons, into orbit. This mission verified stage design utilizing high-performance liquid hydrogen fuel. SA-6 placed Apollo spacecraft test hardware into orbit for the first time, and flight verified a guidance platform of the ST-124 type. The ST-124 will be used in future Saturn 1B and Saturn V missions. NASA then declared the development of Saturn I essentially complete in 6 instead of the originally planned 10 missions. SA-7, the first operational Saturn I, successfully launched spacecraft hardware into orbit in a flight to acquire command and service module structural data, to prove out the launch escape system jettison motor, and to provide further verification of the ST-124. NASA and industry will use the remaining Saturn I vehicles to launch Pegasus meteoroid technology satellites. Fairchild Hiller delivered the first Pegasus payload, a fully operational engineering test model, in late December. The company is developing the Pegasus under the direction of NASA's Office of Advanced Research and Technology. In space, the Pegasus wings will extend to detect the frequency and size of meteoroids. The first Pegasus payload was mated with its Saturn I launch vehicle in January 1965. As development testing and unmanned flight operations continued, the confidence level in critical manned spacecraft designs was increased by the data from Ranger 7, which was launched in July by NASA's Office of Space Sciences and Applications and the Jet Propulsion Laboratory, and which successfully transmitted to Earth the first close-up photographs of the lunar surface. During the past year, there were many achievements in the manned spaceflight programs, achievements including the continued buildup of the government industry team, the accomplishments in manufacturing and development ground tests, the rapid construction of massive facilities, the training of flight personnel, the success in flight operations. The foundation is being laid. This nation is now ready to employ its rapidly developing capabilities for manned operations in space.